Okay, took a little break from our binary to decimal, decimal to binary number conversion. You guys remember that from our last session where we were working on that. Hopefully you had a chance to practice that a little bit, tried some different base 10 numbers and converted them to bytes, took some different bytes and converted them back to base 10 numbers. We're going to need those skills today, and we're going to need the same table. We're going to use the same tools to do what's called classical subnetting. Today we're going to take and we're going to cut up a pie. Think about going to Sherry's or a restaurant like that where they've got pie and you're ordering dessert. They always bring you the same size slice of pie. Doesn't matter that you're a hungry guy like me or that you're a petite eater like my daughter, you're going to get the same slice and the same size. So that's classical. We can compare that to variable length subnet masking VLSM, where we do a pie that's specifically cut to the needs of your appetite. We're going to, in this case, give every segment of the network in classical subnetting the same number of IP addresses. So we're going to take our network address, we're going to cut it up into equal pieces for each segment of the network. So before I do that though, I want to talk about different network sizes. And one of the big things from our text that you read about was the classes. There were a few classes that we talked about. So what was a really big network? What was that class size?
Class A.
Class A, good. We'll put A up here on the board, so the different classes. So Class A. And what was indicative, or what made a Class A network? What, do you remember the sizes of these networks? They were pretty big, right?
Starts at 1 to 126.
Okay, so, when you're looking at IP address ranges for a Class A network, they start, and this will be our indicator. If you look up here, you can see on the whiteboard I've written an IP address. This is a 197. So that first octet there, we're going to be looking at any number between 1 to 19. What did you say there?
126.
126, okay. Good to know. And then we're going to have a Class B. What would a Class B? Anybody looking that up on Google out there, help me out. What's a Class B network range?
128 to 191.
Okay, you'll notice that we're missing a number here. We're missing the number 127, and that's a reserved address. That's what they call the loopback address. So it's got a purpose in networking, and we're not going to be able to assign that. IANA doesn't get to assign that number to our network. So we've got network first octet starting with 128 to 191 for Class B. Let's look at Class C. What is Class C's IP address range?
192 to 223.
223, okay. 192 to 223. Now, based on our Class A, Class B, Class C ranges, what is this network that we're going to be working on to subnet today? At 197, what does that fall into? What range?
Class C.
Class C, good. So we're going to go with Class C. That's a Class C network. And we're going to talk about default subnet masks. Default subnet masks for a Class C network. Not a specific one for this network, but a default one would be 255 dot what?
255.
Dot 255 dot
255.
dot 255 dot
0.
Okay. So we're going to be worried about that last octet here. And I want us to now take our papers and pencils out again so that we can follow along with me. And I want us to draw that table. We're going to draw it here, I guess. Let's draw that table. And we'll draw with the 3 lines dividing it up here. Okay. And we'll start in the top left corner again with the number 128. And then half of that is 64. Half of 64 is 32. Half of 32 is 16. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. And then half of 2 is 1, right? We still need to worry about the powers of 2. So I'm going to start over here in the right corner under 1, 2 to the 0 power. Anything to the 0 power is 1. Then I'm going to put the number 2 to the first. Anything to the first power, 2 to the first is 2. Then we're going to say 2 squared to the second power is 4. 2 cubed is 8. 2 to the 16, 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. And 2 to the 7th is 128. Okay. Now, as I look at this particular address and what we've got going on here, I know that IANA, the body that's been charged with the responsibility of giving me an IP address, has given me this great IP address, 197.14.88.0. And with that address, I've got to cover 16 different subnets on my network, and on each subnet, no more than 14 hosts. There may be 3 devices on one subnet and 8 on another, and 13 on yet a third subnet. Doesn't matter. I've got to make sure that it covers 16 subnets and 14 hosts. So I've got some questions I'm going to ask, and I'm going to use my table to answer those questions. So I'm going to say to myself here, 16 subnets. What power of 2 would cover those 16 subnets? Anybody?
2 to the 4th.
2 to the 4th. So I'm going to circle that 4. That's important. 2 to the 4th. Okay. So we talked about the 8 bits there in that last octet. I'm going to borrow 4, and I'm going to put 1s to indicate that. 1, 2, 3, 4 from my leftmost portion of my host. And then I've got another question I need to ask. I need to ask about the hosts. And with these 1s here, I'm just going to put in 0s in the rest of those. And I'm going to ask the question, how many 0s to the n minus 2, excuse me. Try that again. 2 to the n minus 2. So I'm going to ask, how many 0s do you see there?
4.
Okay, so I'm going to say 2 to the 4th minus 2. So my n is replaced by the number of 0s, right? So 2 to the 4th is 16. 16 minus 2 is?
14.
14. And does 14 cover 14 hosts?
Yes.
Okay, great. Now, we needed to make sure that it did 16 subnets, 14 hosts. We have a byte that was formed out of all of our calculations and questions that we asked. What we're going to do with that byte is turn that base 2 number into a base 10 number. So let's do that right now. My base 10 number on this. So I'm going to take that first 1, and I'm going to add 128 to my second one, which is 64. What is 128 plus 64?
192.
192, good. The math people helping us out. 192, and then I've got to add that next one. What is 192 plus 32, math people?
224.
224, okay. Again, we'll check our math on that. It's got to be spot on. And then one more 1 here. What is 224 plus 16? So 240?
Yeah, I think so.
Okay, yeah, we think so. Check it. Get your calculators out. Remember, we've got those on our Windows boxes. Our Windows 10 machines have a built-in app, a calculator on that desktop. So use that. 240? Is that what you guys came up with? We're checking right now. I see lots of people out there furiously, fast fingers typing that in. Let me know. They're checking my math. Make sure. This is important.
Yep.
Okay, good. So it is 240. What we're going to do with that 240 is now we're going to have an actual subnet mask. Remember, this was the default subnet mask? We're going to do the actual subnet mask, and it's going to be 255.255.255. What?
240.
240, exactly. So this is the actual subnet mask. Okay. This is good, and this is taking us a little farther from what we were doing with base 10. We did our base 2, base 10. We now know about the different classes of the networks. What we want to do now is take the IP addresses and assign them to the 16 different subnets and make sure that each host has an IP address that it can use, meaning making sure that all the computers in there, the printer, everything that needs an IP address in your network has that available to them, and also that we keep a couple of reserved addresses. Let's get a new piece of paper out and a pencil, and let's do the following drawing. We're going to create another table here. We're going to say net ID, and we're going to say subnet mask, and then we're going to say first usable, and then we're going to say last usable. Usable as in addresses, IP addresses, first usable IP address, last usable IP address. And then we're going to have our broadcast. My net ID for this first subnet, it's going to be what Iana gave me. And what was that? You guys read that over there? It was 197 what?
14.88.
14.88.0. So that's my net ID. That's a reserved address. My subnet mask is going to be the same because this is classical subnetting. And so each one is going to have the same subnet mask.
255.
255.
.255.
.255.
.255.
.255.
.240.
.240. I'm just going to draw arrows down there like that, indicating that it's the same all the way down. Now my first usable address, math people help me out. If 197.14.88.0 is the net ID, what is one directly after that? What is the IP address directly that follows the 0? 197.14.88. What?
1.
1, good, okay. Now the last usable, that's not so easy for us to figure out, but maybe it is. Let's look over at our math that we did previously. And it looks like my 2 to the n minus 2, that produced 16 minus 2, giving me 14. That 16 is an important number as well. And every 16, this is going to increase. So I know that 197.14.88 is the same. And I look over there, and this second subnet is going to start at 16. And that's all based on my 2 to the n minus 2. That's how I know the increments of each of the subnets. So this is subnet 1. This is subnet 2. How many subnets do we have total?
16.
16, okay. So we got some work ahead of us. So if this is 16, I'm going to backtrack a little bit and ask you, what is the number that is right before 16?
15.
15, okay, so my broadcast address on the first network is 197.14.88.15. And the number that directly precedes 15, the one right before 15 is?
14.
14, good. So the last usable address is 197.14.88.14. This is our whole first subnet right here. This is our first subnet. You can see here, everything is taken care of. Now we've already started in on subnet 2. We have our new net ID. And the net ID is 16, so again I asked the question, what is the number that directly follows 16 for our first usable?
.17.
197.14.88.17, that is correct. And I've got to remember that these increases by 16 each time. So subnet 3 is going to be 197.14.88. What is 16 plus 16?
28.
No. Try again. 16, 16, 32, right?
Oh, yeah.
Okay, good. So we got to check our math at all times, because if we get off mathematically on one of these steps, the whole thing goes kapooey. We don't want that to happen. So I'm going to look at this 32 and know that up here on the previous line, the broadcast address is going to be 1 before 32, which is
31.
31, good. 197.14.88.31. And then the last usable is going to be one number before 31, which is 197.14.88. What?
30.
Yeah, 30. Good, okay. So I have completed again all of subnet 2's addresses. Again, this is a reserved address to NetID. It can't be used on any of my computers, so I'm not using that as a host machine IP address. And my broadcast is also another reserved address. What I can use for my printer and my computers, I can use the usable range here. My first one on this network would be anywhere from, so I could use 197.14.88.19 on your computer up here in the front row. That could be your IP address. It is a usable address if you were on subnet 2. Okay, we continue this down. I'm gonna do 4 today. I'll do 4 of these, and I won't do all 16, but you can see the process. Okay, so 197.14.88.32. The next one here is 197.14.88. What's the number right after 32?
33.
33, good. Okay, and I'm gonna add 16 to 32. What do I get? 16 and 32.
48.
48, okay. All right, so 48. 48, the number right before 48 is 197.14.88.47. And the number right before 47 is 197.14.88.46, right?
Yes.
Okay, so we've handled subnet 3 here completely. Sub 4. 197.14.88.48 is the net ID, a reserved address. The first usable address building on that is one right after that, 197.14.88. And the number right after 48 is
49.
49. Good, you guys are seeing this. Excellent. Okay, I've got to, in order to flesh out my broadcast address, add 16 to 48. And what is that? 16 and 48, get your calculators out if you need to. Help me out, math people. Sub 5 here, what would that be? Dave, you're in the front row, what'd you come up with there?
That's 64.
64, excellent. So 64, and 64, the one directly after that would be 65. And so 64 here, oops, 64, sorry, didn't quite carry that over for you. 64, the previous broadcast address, then is going to be 65. So 197.14.88.65.
63.
60 what?
3.
3?
So one before.
64, whoa, hey, good catch, see? Don't follow me down that dark road. Make sure you're always paying attention, and you guys were. I'd like to say that I did that on purpose, but you guys caught me making a mistake. Good. 63, 197.14.88.49. So 63, the number right before that, building on your last statement you made to me, would be what?
62.
62. Good. Excellent catch, excellent save. So you can see now we have all of subnet 4. You're going to get down to the final ones, and remember 255 is the highest number you can have. But you may, down here in the subnets, actually have to have 256 down here so that you can have 255 over there. So just keep adding 16 until you get to the very end, subnet 16. Okay, any questions? All right, practice that. Let us know on the discussion board if you have any questions, or come see me or email me. Okay.